Okay, welcome aboard. Let's do Eigenvectors, BRNY-Style. You're given a matrix. Step 1, you'll set up the standard form. A minus lambda I. A is the matrix you were given minus lambda times the identity, I. We'll distribute lambda into the identity, giving us A minus lambda times identity. We'll do the operation across. 6 minus lambda is 6 minus lambda. Minus 1 minus 0 is negative 1. Minus 1 minus 0 is negative 1. And 8 minus lambda is 8 minus lambda. Step 2, we will find the determinant. The determinant of a 2 by 2 matrix, D, is A times D minus B times C. We're talking about this guy right here. So let's set it up. A times B minus B times C minus B times C. You'll do the operation and you're going to get something messy. You'll put higher ordered terms to the left, combine like terms, and you'll be left with a quadratic equation. Something squared, something single, and then a scalar. Step 3, we'll use the quadratic formula. Phi equals negative b plus or minus square root b squared minus 4ac all over 2a. In this case, a is the coefficient of our squared term, b is the coefficient of our singular term, and c is our scalar. A is 1, b is negative 14, c is 47. We will put these values into our quadratic formula, giving us negative b, or negative 14, which is 14, plus or minus b squared, which is negative 14 squared, 196, minus 4 times a times c. So 4 times 1 times 47, 188. All divided by 2. We'll simplify, and we're going to get 7 plus or minus the square root of 2. So phi 1 is going to be 7 plus root 2, or 8.414, and phi 2 is going to be 7 minus root 2, or 5.586. Step 4, sub phi values into step 1. Step 1 was the standard form here. For phi 1, we had 8.414, so 6 minus 8.414, negative 1, 8 minus 8.414 is equal to this matrix. For phi 2, it will be 6 minus phi 2, which was 5.586. 6 minus that, negative 1, 8 minus that equals this matrix here. Step 5, we will use row reduction in augmented form. Augmented form is the previous matrix with the big line and then 2 zeros on the other side. For phi 1, we'll write out our original matrix that we had from the previous step, and we'll assign columns x1 and x2, 2 zeros over here. The row reduction happens like this. We want to eliminate all values from row 2 and make them all zeros. So we have a negative 1 here. We're going to divide row 1 by negative 2.414, and then we're going to add it to row 2. That's going to give us our new row 2. In this process, row 1 will not change. So let's go through it. First column, negative 2.414 divided by negative 2.414. That gives us 1. Negative 1 divided by 2.414 gives us 0.414. We're going to go ahead and add that to row 2. 1 plus negative 1 is 0. 0.414 plus negative 0.414 is 0. So now we will rewrite the matrix. Remember, row 1 did not change, so this row 1 is identical to this row 1. And now we have zeros for row 2. We will assign these values to our columns x1 and x2 to create this equation here. Negative 2.414x1 minus x2 is equal to 0. Boom, boom, boom. Now we'll put x2 on the other side, and we're going to say we're going to let x2 be equal to 1. And now we're solving an equation with one variable. x1 is equal to negative 0.414. Moving on to phi 2. We'll take our original matrix, put it in the augmented form, and assign our columns x1 and x2. We have a negative 1 here, so we need to turn this into a 1. We'll take row 1 and divide it by 0.414. We'll add it to row 2, and that will give us our new row 2. Remember, row 1 will not change. So 0.414 divided by 0.414 is 1. Negative 1 divided by 0.414 is negative 2.414. 1 plus negative 1 is 0. Negative 2.414 plus 2.414 is 0. Row 1 did not change, and now row 2 is a family of zeros. We'll assign our columns by the x1 and x2. 0.414x1 minus x2 is equal to 0. We'll move x2 to the other side. 0.414x1 is equal to x2. We will let x2 be equal to 1, and then we'll solve for x1. x1 is equal to 2.415. Step 6, write the eigenvectors. For phi 1, we had x1 is equal to negative 0.414, x2 is equal to 1. So x1 is equal to negative 0.414, x2 is equal to 1. v1, or eigenvector 1, is negative 0.414, 1. For phi 2, we will recall that x1 was equal to 2.415 and x2 was equal to 1. x1, 2.415, x2 equal to 1. v2, or eigenvector 2, right here. Final answers, v1 and v2. And that's eigenvectors, BRNY style.